Okay, so we are going to go through the Edexcel iGCSE Maths Paper 2H from June 2018. So, question number 1. Make A the subject of the formula. So we've got M is AC minus BD. So we're going to try and get all the A's on one side and everything else on the other. And we do that first by addition. So we're going to try and get the BD. So we're going to add BD to remove it from this side. But what we do to that side, we must do to the other side. So we're going to add BD to this side. So we get M plus BD on this side equals AC minus BD plus BD, so that's just AC. Now we're going to try and get A on its own, so we have to, it is A times C, so we're going to have to divide by C. Divide both sides by C. So this side A times C then divided by C just leaves us with A. And this side I've got M plus BD, and I want all of that divided by C. So we write a big line to mean all of that divided by C. So that's our answer. A equals M plus BD over C. Now there are other ways of doing this depending on the order that you do it in, but I think that is the most straightforward. And one of the reasons is it also mirrors what we want to do for the next one. So this one we want to get x on its own. So this operates very similar to if you've got an inequality, so an equal sign. So we want to get x on its own. So we're going to add 4 to both sides. So we get 5x is minus 4 plus 4 is nothing, is less than 43. So we're going to get x on its own, so as above we divide by 5. So divided by 5 we get x is less than 43 over 5. And we can leave it like that, or we can work out that 43 over 5 is 8 and 3/5, or 8.6. And then we write on our answer line, and you must write the x is less than 8 and 3/5. If you just write 8 and 3/5, you only get one of the 2 marks. Okay, now part C says fully factorise. So this bit is really important. We want to fully factorise this. So that means take as much outside the brackets as you can. So first of all we look at the number. What's the biggest number that goes into both of those that we can take out? Well, 2 goes in, 3 goes in, and if 2 and 3 goes in, then it must mean that 2 times 3 goes in, so that's 6. Anything bigger than 6 go in? Nope. So 6 can come out. Then how many e's? Well, you've got e squared and e cubed, so the biggest number that can come outside is e squared. F's is f cubed and f, so the biggest number is just 1f coming outside. Then you look at what's needed to make this statement now true. 6 times what makes 18? 3. E squared times what makes e squared? So that's just 1, so we can leave that there. F times what makes f cubed? So that's f squared. Minus, and then the same for the other one. 6 times 2 makes 12. E times e squared makes e cubed, and the f is correct. So there we have it. That is fully factorised. That's the most you can get outside, and that's what gives you your 2 marks. Okay, work out the difference between the largest and the smallest share when 3,450 yen are divided in the ratio 2 to 6 to 7. So let's go for this the longest way around. There are other ways of doing this, but if we just divide it in the ratio and then see what happens. So we want 2 to 6 to 7. So the total of the ratio is 8 and 7 is 15. And we want that to go into 3, 4, 5, 0. Okay, so how many times have we got to multiply that ratio up? Well, 3, 4, 5, 0 divided by 15 will tell us how many times we've got to divide that ratio up. 3, 4, 5, 0 divided by 15 is 230. So I've done that sum on my calculator, but I've written down that that's the sum that I've done. So we now want to times each of these by 230. 230 times by 2 is 460, times 230 times 6 is 1380, and 230 times 7 is 1610. Okay, we can check that that's correct. Just adding those up, and that comes to 3450. Then we've got to make sure we answer the question. Work out the difference between the largest share and the smallest share. So the largest share is 1610, and the difference between that and the smallest share, which is 460, 1610 minus 460. And as I said, there are other ways of doing that, but that I think is the most straightforward. There. Okay. So Gopal is paid 20,000 rupees each month. Jamuna is paid 19,200 rupees each month. Gopal and Rupi are both given an increase in their monthly pay. After increase, they are both paid the same amount each month. Gopal's increase was 8%. Work out the percentage increase that Jamuna was given. So, Gopal was given an 8% increase. So, 20,000. Then you've got an 8% increase. So, I think a couple of ways to do this. You can either multiply by 0.08, that gives you 8% straight away, or you can divide by 100 to get 1%, and times by 8 to get 8%. So if we do that, 20,000 divided by 100 to get 1%, times by 8 to get 8% is 1,600. So Gopal new pay is 21,600. And then we want to work out what is the increase for Jamuna. And so we've got the increase that she would need to get. If they're to be paid the same, is 21600 minus. So this is the actual increase. Which is 2,400. And we want that as a percentage. So the percentage increase, we write it as a fraction of the original price. So how much was it originally? 19200. And then that's a fraction. To get it into a percentage, we times it by 100. So divide by 19200 by 100 is 12.5%. So that is the percentage increase is 12.5%. And you can check that by adding 12.5% onto 19,200, checking it gives us the right value. Okay, question number 4. Show that. So you've got the answer, so you can't just use your calculator, you've got to show some working. Show that 3 and 4/7 minus 1 and 5/8 equal 1 and 53/56. So again, a number of ways of doing this. I think the easiest and most standard that then works for all fraction questions is the first thing you do is you turn it into a mixed number. So 3 whole ones and 4/7. So that's 3 times 7, which is 21/7, plus another 4/7 is 25/7, minus 1/8 is, that's 8/8, plus another 5 is 13/8. Now, you can't add 7ths and 8ths together, so you've got to turn them into something that they both go into. So 7 times 8, they both go into 56. So how many 56ths? Well, 7 times 7's here, 7 times what gives 56, or 7 times 8. So 25 times 8 times top and bottom by 8 doesn't change the size of the fraction. So that's going to give me 200. And then times by 7 for the other fraction. So times top and bottom by 7, that gives you the 56. 7 times that is 91. So then you've got 200 minus 91, which I make 109 over 56. And then you've got to write that 159 you know is 1 whole one. That would be 56. And then it's 53/56. And that's enough, but you must write that down at your end to say that you've ended where you were starting. If you wanted to write a little box here, you could say 56 plus 53 is 109. That would give you an indication that you're on the right track. But you don't need this. There you go. There you have it. You've shown that that is true. Okay, in the diagram below, P and Q are points on the circle with centre O. QT is a tangent to the circle. If OPQ is 18 degrees, give a reason for PQT. So PQT, P to Q to T, we're after that angle there. Okay, well, what do we know in this? Well, the first thing we know is that we know that OQT, angle OQT is 90 degrees. And it says give a reason for each stage. Well, I know, and you've got to learn these rules, that the tangent meets the radius at 90 degrees. Tangent meets the radius at 90 degrees. That's the first one, so we know, let's put it on our diagram, we know that that is 90 degrees. So we need to know what this little angle in here is. So we need to know that OQP, so O to Q to P, this angle here, well, this has 2 radii, so that forms an isosceles triangle, so that's 18 degrees. And why is it? Because base angles of an isosceles triangle are equal. So the angle that we want is PQT, is that whole thing, 90 minus the 18, which is 72 degrees. There we go. Okay, the diagram shows two cylinders A and B. A has a height 1.6 and radius 0.56. Work out the curved surface area of cylinder A. Well, the curved surface area is actually, imagine this, taking this bit here, this is then going to be all flattened out. So this length, it then forms a rectangle, quite long, which is going to be 1.6 meters high, and then this is actually the circumference of the circle, and we know the circumference equals pi times the diameter, and we know the diameter is twice the radius, so the circumference equals pi times 0.56 times 2. So if we work that out, times 0.56, and it says to three significant figures, so I'm just going to write lots here, 518,583 for now. So the area, well, is actually just a rectangle. So it's 3.518,583 times 1.6, which equals 5.629,734. And it wants it to three significant figures. So 1 is the 5, 6, and then the 2. Does that round up? Yes, because it's 9. So it's 5.63 meters squared to three significant figures. Okay, part B. The cylinder is mathematically similar. So one, that means one is an enlargement of the other. Okay, what is the radius of cylinder B? Well, how do we get from A to B? Well, how many times bigger is it, or how many times smaller? So how do we get from there to there? Well, we divide by 1.6, we multiply by 0.6. Divide by 1.6, multiply by 0.6. That will give us that one there. So if we do the same with the radius, we divide by 1.6, multiply by 0.6, divide by 1.6, that will give me 1, multiply by 0.6, that will give me, how many we've got here? So 0.56, divide by 1.6, multiply by 0.6 is 0.21 meters. That feels about right. half of it. Okay. Going to keep going. Number 7. Students in Class A and Class B take the same exam. 28 students in Class A and 32 students in Class B. The mean students for all the students in both classes is 72.6. The mean score for the students in Class A is 75. Work out the mean score for the students in Class B. Okay, so means are difficult to deal with, but we can deal with totals. So the key is the total score. So the total score for both is the mean times by how many are in both. So there's 28 and 32, so that makes 60. So the total for both 72.6 times 60, which is 4356. And we can work out the total for A as well. Total for Class A. Well, they've got a mean of 75. They've got 28 students. 75 times 28. So now we've got the totals for both. Well, now we think, okay, well, we can get the total for Class B. Well, that's the total, what it was in total, minus the total for Class A. Which is 2256. And now we can get the mean, because the mean is the total divided by how many there are. And how many are there in Class B? Well, there's 32. Which is 70.5. Okay. The lowest score in Class A is 39. So we've got Class A, we've got the lowest score is 39. The range of scores for Class A is 57. So that's the lowest score. So the range is 57. So can we work out the highest score? I think we probably can. 39 plus 57. So the highest score is 96. Class B, the lowest score is 33. And it's 60 range. So I can do that, that's 93. Find the range of scores for all the students in both classes. Well, you've got the lowest score is 33, the highest score is 96, so the range is the difference between those. 96 minus 33 is 63. Okay, work out the value of x. Give your answer correct to 3 significant figures. So x, so this is a triangle. What lengths have we got? Well, that's that. We've got the hypotenuse, that's the diagonal longest length. This one's the opposite. Not really interested in the opposite, but we do have the adjacent. So we need to look for one of our ratios that has that in, and that is the cos ratio. So the cos of the angle is the adjacent times the hypotenuse. So cos of the angle is the adjacent over the hypotenuse. So we want the hypotenuse. So the hypotenuse equals the adjacent over the cos of the angle. Okay, just from this triangle there, I realise that's a little bit black box. You can do the more algebraic way. We can put in the adjacent, which is 12.6, over the cos of the angle. Make sure your calculator mode is in degrees, and we can work out that x is 12.6 divided by cos 52, which is 20.466. So three significant figures is 20.5 centimetres, because the 4 rounds up, because 6 is bigger than or equal to 5. So 20.5 centimetres. Okay, question 9, simultaneous equations. Ooh, lots of ways to solve simultaneous equations. We could go for substitution or for elimination. I'm going to go for substitution to begin with. So I want to rearrange one of them to get x equals or y equals. And generally this is possible. Looking in the top one, I could rearrange the top one to get x equals, by minusing y from both sides, I get x equals 15 minus y. Okay, then I'm going to substitute when I see x in the other equation. So instead of writing 7x, I'm going to write 7 15 minus y minus 5y equals 3. So the rest of the equation I've written actually exactly as it is there. Okay, just where it says x, I've written 15 minus y. So this method is called substitution. So then I multiply it out the bracket. So 7 times 15 is 105 minus 7y minus another 5y equals 3. So I'm going to take the minus 7y minus 5y over the other side. So I'm going to add that 105 because I want a positive number of y's equals 3 plus 12y if I do that all in one go. Take the 3 off, I get 102 equals 12y. So I've taken 2 off both sides, so y equals 102 divided by 12, which is 8.5. Okay, or 8.5. And if y is 8.5, then according to my statement in my box, x is 15 minus y, which is 8.5. So that's 7.5. Now the great thing about this is I can check that this works. So does it work in the first statement? Yes. 8.5 plus 7.5 is 15. Tick. It works in that statement. Second statement, 7 times x. I'm going to need my calculator. 7 times 7.5 plus minus 5 times y, which is 8.5, equals and that's not right. So we know we've made a mistake. So let's go back and check. Let's try redoing that subtraction. So 15 minus 8.5. We notice, I can't do that. So that's a really good example of why we do a check, because actually I can't subtract, and that should be 6.5. Now let's just check. 8.5 plus 6.5, does that give 15? Yes. Now 7 times x, which is 6.5, minus 5 times 8.5 equals 3. So tick, I know that I'm right. X is 6.5 and y is 8.5. There we go, good example of how to check and not make silly mistakes. Okay, keep going. Yeah. Making good progress. Okay, find the value of n. So they've made this slightly more two-step than the simplest version of these questions. So the first thing you've got to do is you've got to put the whole thing in powers of 2. So 8, do you know what the power of 8 is? Well, you can do it by trial and error, but 2 to the 3 is the same as 8. So this 2 to the n is 2 to the 3 divided by 2 to the 7. If we divide the powers, we're going to subtract them. So this is the same as 2 to the 3 minus 7 is minus 4. Okay, and you can check that out. You can type in 2 to the minus 4 and it'll give you the same answer as if you've got 2 to the 8 divided by 2 to the 7. So what's the value of n? Well, n is the power here, so n is minus 4. Okay, and then with the next one, we've got 13, so here to the minus 6, so we've got 13. We multiply those powers, so it's that many lots of it, so it's 24 times 13 to the 5, and then if we're multiplying, we add the powers. So the very basic example is you've got kind of 8 squared times 8 cubed. That would be 8 times 8 times 8 times 8 times 8. So that's 8 to the 5. So you can see from that example we've got to add the powers. That's just a little aside example. So here we add the powers. So minus 24 plus 5 is minus 19. So we've got 13 to the minus 19. So what is the value of k? So the value of k there is minus 19. Okay. A solid metal sphere has radius 1.5. The mass of the sphere is 109 grams. Work out the density. So you do need to know density, and you also need to know volume. So we get a nice helpful sheet for all the volume things that we need. So we'll go back to the beginning of the paper, just remind ourselves and show ourselves what we get given. So here we get given volume. There you go, volume of a sphere, okay, is 4/3 times pi times r cubed. Okay, so let's go back to our question. I'll get there. Be quicker for you on paper than this bit. There we go. So, and then we need to know what density is. So density is how heavy per unit mass it is. So it actually gives us here a bit of a clue. If you look down here, it says density is grams per centimetre cubed. So we need the number of grams, which is the mass, divided by, because it's per, divided by centimetres cubed. Well, that's the volume. So if you forget, always look down at the units because they can be a real help. Density is mass divided by volume, so that's 109.6. we're wanting it in grams, so it's in the right units, divided by the volume. Oh, we don't know the volume yet, but we do know the formula for the volume. So let's just hold that thought. Over here, go the volume. We can remember was 4/3 of a sphere times pi times r cubed. So it's 4/3 times pi, which I've got on my calculator, times 1.5 cubed. So 4 divided by 3 times pi times by 1.5 to the power 3 is 14.13716. Using lots again, so density is mass over volume, so I've got to divide by this number. Equals 10.6 divided by the answer is 7.7526. We want it to 3 significant figures, so it's just 7.75, just those first 3 numbers. Grams per centimetre cubed. So density, mass divided by volume. Okay. Diagram shows a hexagon and BC is parallel to ED. So BC is parallel to ED. So those two things are going to be really important. Work out the size of angle DEF. Well, we've got parallel lines here. So parallel lines means that there are some pairs of angles. Well, we've got those co-interior, sometimes called C angles, in there. We can see they're not equal, but they do add up to 180 degrees. So we can see that EDC, that one I've marked, is 180 minus 42, which is 138 degrees. So if I just put that on there, that's clear. And then I'm trying to work out the size of the obtuse angle DEF, so I'm trying to work out that angle there. Well, this is a hexagon, so I know what the angles in a hexagon add up to. So angles in a hexagon, well, I can either go up from a triangle that's 180, square is 360, and keep adding on 180 each time, or I know that it's the number of sides minus 2 times by 180. So it's 4 times 180, which is 720. So it's always the number of sides, take away 2, and it's that many triangles effectively in the shape. So 720. So I've now got all the others, and take that away from 720. So I've got 720 minus 50 minus 96 minus 138 minus 144 minus 42. It's going to leave us with equals 250 degrees. So this here is 250 degrees, and it says work out the size of the obtuse angle. So obtuse is more than 90, but it's less than 180. This here is the reflex angle, so it's saying actually we want to have this one here. So that is just, so the reflex angle is that, so the obtuse angle is 360 minus the 250, which is 110 degrees. There you go. 5 marks for that. Look at that. Look at those 5 marks. I think that's, at least some of that is doable, but I think all of that is something that we can do. Okay. Felix has 10 cards. 5 red, 4 blue, 1 green. Felix takes at random one of the cards. He doesn't replace it. Felix then takes a second random card to complete the tree diagram. So going along here, he's taken out a red card. How many reds are there? Well, there's now only 4 reds because he's taken one out. Out of how many cards? Well, there's only 9 cards. How many blues are there? Well, there are still 4 blues, but there are only 9 cards, and there's still 1 green. In this route, if he takes out a blue to begin with, well, there are still 5, but there are only 9 cards. Taken out a blue, so there's only 3, still out of 9. Taken out a blue, there's still 1 green. And then going this way, taking out a green, well, there's no greens. Oh, out of 9, sorry. How many reds are there? Well, there's 5 reds. There's 4 blues. Work out the probability that Felix takes at least 1 blue card. Well, that's just asterisks, all the one with 1 blue card. Well, that's got at least 1. That's got 2, so that's at least 1, and that's got, so those are the ones we want. So that's 5 tenths times 4 ninths. That's 20 over 90. This is 4 tenths times 3 ninths. That's 12 over 90. And this one is 1 tenth times 4 ninths, which is 4 over 90. So altogether, that's 20 over 90 plus 12 over 90 plus 4 over 90. I make that 36 over 90, which if we simplify that down, that becomes, divided by 9 is 4 over 10, which is 2 over 5. Oh, I've missed some out here. That one's got a blue one, and that one's got a blue one. Apologies. So we've got 4 over 10 times 5 over 9. So that's 20 over 90. And we've got this one, which is 4 over 10 over 9, which is 4 over 90. Apologies, we've got to add in a few more here. So, plus 20 over 90 plus 4 over 90, 40, I still haven't read the question right. Takes at least 1 blue card and no green card. So no green card means I don't want this one. Let's rub out this one. I'm going to take out there. Okay. Third time lucky. Let's try reading the question. 20, 40, 52, 56 out of 90. I think I should start this question again, but I'm not going to because you're getting the idea. No green card. Sorry. Really concentrate. So there's not that one. So there's not that one either. So actually, it's 52 out of 90, which feels correct. Apologies about that, but I think you now get the idea. At least one blue and no green, so I need to find all the routes that have at least one blue and no green, so I'm not allowed any green in there. Okay. Question 14. Complete the table of values for this. So the key to this, particularly when doing the -1, is that when you put it into your calculator, you cube it, you must put a brackets around the negative. So I'll write it out this one, but you'll get the idea. When you're doing the positives, calculator's not so fussy, but here, because of a bit of maths in the way that it does the index before it does the power before the negative, you just need to put that in the bracket. So if we do that one first of all, so that will be -2 brackets cubed -2 squared -3 plus 4 gives you -6. And then if I do the same for the next one, I get 4. 1 is then easier. It comes to 0, and then this one comes to -2 and 4. Okay, I've then got to plot these accurately onto here. So just going to make this a bit smaller so that I can see it. So -2 -6. So -2 -6. That's going to be exactly on there. Oh, not quite exact. So -2 -6. Let's get that really accurate. There we go. And then the next one, -1 4. So that's -1 along, 4 up. There we go. Next one, -0.5 and 4.875. So -0.5, and so that's along here. Then 4.875. So this would be 5. So going up in 0.2. So it's above that one. So put it in there. 0, 4. So 0 along, so that's exactly on the line there. 1.5 and minus 5 and -1.625 -1. 6 is 3 boxes and a bit. So there. 2 -2. Oh, that should be exactly on there. And 3, 4. Okay. And draw the graph. So it's not just about plotting the points, we've got to join all of those up with a smooth curve. and 1 0 I think I failed to put in. Oh, put the last one wrong, that didn't feel right. 3 4, I plotted 3 minus 4. Didn't feel like I was going to get a smooth curve, so there we go, 3 4. Okay, so that feels a bit more cubic-like. Cubic-like tends to have 2 bends, so I think I can now draw a smooth curve through that. There we go. It goes through all the points and draws a smooth curve. So there we go. That is our curve. By drawing a suitable straight line on the grid, find estimates for the solutions to this equation. Okay, so we've got to get solutions to that equation. We've plotted x cubed minus 2x squared minus 3x plus 4. So let's just write this down here. X cubed minus 2x squared minus 3x plus 4. Okay, so the question is, what do we have to do to this equation to get that one? Okay, because there's got to be some similarities, because they're asking us to use that. Well, I can see that I've got to take 2x off this side, and I've got to add 3. So I'm going to do that to both sides of the equation. So I'm going to, off the other side, I'm going to take 2x, I'm going to add 3. So to this side, that gets that, because that's how I've decided it, and to the other side gets minus 2x plus 3. Okay, you see what I've done? I've kind of taken that equation, I've added some stuff, and so I've said solving this top equation is the same as solving this equation. So it's the same as solving when this line equals this line. So when y equals x cubed minus 2x squared minus 3x plus 4 equals y equals minus 2x plus 3. So I can now plot the graph of y equals minus 2x plus 3. I might want to do a little table. X and y. 0, 1, 2, why not? So 0 is 3, 1 is 1, and 2 is minus 4 plus 3 is minus 1. So 0, 3, 1, 1, 1, and 2 minus 1. So that's the line, so I can now join that up with a ruler. It's a little tricky on here, but I think this will work. That's pretty good. And now I can look at what the x values are that solve that. So there are 3 of them. We've got on my graph that one, which is minus 0.8. And here we've got this one, which is positive 0.6. And this one, which looks like we've gone a little array from here, so for my dot, but according to my graph, it's 2.3, and I'll tell you what the mark scheme says in terms of what you're allowed in terms of your graph. So you're allowed, from this one, you're allowed anything from minus 0.9 to minus 0.7. For 0.6, you're allowed 0.4 to 0.7, and from this one you're allowed 2.1 to 2.4. Okay, so we're well within the tolerance of what you're allowed on the mark scheme. So there we go, there are 3 solutions. 8 marks for the whole of that question. That's a biggie. That's a biggie. You can get your head around that. That's awesome. Okay. Work out the lower bound of E minus F. Okay. E is 8.31 to 2 decimal places. So what is the smallest that can be? Let's just think for a moment. What is the largest each of those can be? So the smallest is 8.305. And the largest it can be is 8.315. Okay, if it was anything more than that, it would be a bigger number. And let's do the same with this one. The smallest it can be 0.645, and the largest it can be is 0.655. We then want the lower bound for E minus F. So we want the lowest it can be. So we want the smallest E, because that's positive, and then we're going to take away the biggest number. So the lowest we can get for E minus F is if we have a low E, that's 8.305, and a big F, 0.655, which is, and these are the numbers you need to show, 8.305 when it says show you're working clearly, minus 0.655 is 7.65 is the lower bound. The upper bound, interestingly, would be you want the biggest E and the smallest F. That would give you the biggest value. Okay, question 16. R is proportional to t squared. Find a formula for R in terms of t. So R being t squared means that we know that R is k times t squared. That's what it means. K times t squared. And actually there are lots of values that it gives you. I'm going to pick the one that, there are 2 that are on whole numbers. There's one there, and there's one there. Okay, let's use the big one because that seems good. So when R is 40, T is 4. So we've got 40 equals K times 4 squared. So 4 squared is 16, so we've got 40 is K times 16. Means K is 40 divided by 16. So K is 5 over 2 or 2.5. So the formula is R equals 2.5 t squared. Given also that R is 8 over 5x, so 8 over 5x is R, and that's, we've shown, is equal to 2.5 t squared. So now we've got to show how they are related. So what does t equal? Well, I don't really care about the numbers when we're talking about proportionality, but let's work them out. So we're going to go, we're going to do 8 over 5 to get t. So t squared is I'm going to do 8 over 5 divided by is 16 over 25. So 16 over 25x. So then I've got t squared, so I want to find what t is. So t is the square root of that, which is the square root of 16 over 25x, which is 4 over 5 times the square root of x, which shows, so t is inversely, because it's 1 over, inversely proportional to 1 over the square root of x. There we go, done. Okay, let's just pause there for a moment and we'll restart in a little bit.